All right, gentlemen, Doc here with another little lecture for you. So we're going to talk about some properties of the definite integral. The first among these properties, and we're going to kind of give a reason for why each of these is true. We kind of talked about them a little bit in class today. But the first among these properties is this guy, the property that says if we reverse the bounds, all I do is I pick up a minus sign. All I have to do is pick up a minus sign. So for instance, let's just do a little example. The integral from 1 to 3 of 2x, well, that's going to be x squared from 1 to 3. So this is what, 9 minus 1, this is 8. So I can see immediately the integral from 3 to 1 of 2x is just going to be, we need dx. It's just going to be negative 8. It's just, you throw a minus sign on it. Or, if it was already negative, we throw a plus sign on it, right? We just change the sign. And why is this the case? Well, if you ever think about it, the only difference between these two things is the bounds, right? So if I was just to do this integral guy, we have that like big mystical antiderivative, that f of x. So this is f of b minus f of a, right? And if I pretend this negative sign is not here, this side over here, this is f of a minus f of b, right? That big F, that big mystical F. And how are these two related to? This is just the negative of that guy. So we can put that minus sign back in there to restore our equality. This restores our equality. And you're going to have some examples later where you have to play with some of this stuff. So this next guy, if I go from A to B, then I go from B to C with the same function, that's the same as going from A to C, right? And this is area under the curve stuff. Right? We just throw some A's, B's, and C's here, right? This first integral, I use some different colors. This first integral, the red guy, is just this area under this curve, right? This second integral, this is the area under this curve. So then we have this third integral, this third guy, right? How do I do it to get from A to C? Well, all I do is I just calculate it all at once instead of doing it individually, right? Calculate it all at once instead of doing it individually. So it's kind of, it looks a little crazy, but it's kind of pretty obvious, right? Even functions, these are symmetric about the y-axis. An even function is symmetric about the y-axis. So it might look something like this. I'm going to say if this guy goes like this, then it's going to go like this, right? It's symmetric about the y-axis. And that's not perfectly symmetric, but you can imagine. I'm going to draw it again. That was pretty bad. There's a little more. Here's something that's a little more symmetric, right? And we're going from negative a to a here. So we're going from a negative number to a positive number. And since it's symmetric about the y-axis, the area in this piece is equal to the area in this piece. These two areas, these red areas, are going to be equal to each other, right? So what can we say? Well, instead of going from negative a to a, since we're really just calculating the same area twice, I can just do twice from 0 to a. So I can go from here, I can figure out how big this is, right? I can figure out how big that is, and then I multiply by 2, and then just multiply by 2. That's another fact about integration. And we'll put it to play again in a little bit. If f(x) is odd, this is a cool one. So you remember an odd function. I'll do a different example maybe from a class. Here's an odd function. right? So here's an odd function. It's symmetric through the origin. Symmetric through the origin. Symmetric through the origin. And if I go from negative a to a, say negative a here, because it's symmetric through the origin, excuse me, the area here, numerically, the area here and the area here, the raw area, they're equal to each other, but this guy has negative sign, right? So while these areas are equal to each other, that guy has a negative sign. So when I add them, when I kind of add them up, when I add them together, when I calculate their area, we get 0. And so there's some facts about even and odd functions and some derivative facts. You'll have some time to practice with it in a little bit. Next guy, we got an example of a piecewise function, right? And now this guy's actually pretty. It looks maybe like it'd be a little scary, but it's pretty straightforward. So the big issue is here we have this. Let me do like this. This guy and this guy, right? So the big issue is here we have this junction point where these functions might not be continuous, right? In fact, it's probably not. I think it's definitely not. So we are not continuous to 7, but we can still handle this integral. So let's think about it. This first guy, this is on the interval -1 to 4, right? The interval of -1 to 4. Well, that lives completely in the kind of green section here, the x is less than 7 section. So if I want to calculate this, actually all I do is this is the integral from -1 to 4 of sine of 3x minus 4. Right? And I'll leave you alone to figure out what the answer is. So since this lives completely in the green section, this is what that integral will be. Similarly, since this guy lives completely in the red section, this right here, we'll go from 8 to 12. And again, we just need the red integral, right? So this is every number here is bigger than 7. This is 8 to 12. So all we need to do is 3 over 2x minus 1 dx. I've got a dx over there. Dx. Okay? And then finally, this guy, maybe I'll do it in purple. This guy, okay, he kind of lives in both, right? From 4 to 7, he lives over here. And from 7 to 9, he lives over there. So the integral here is just the obvious thing. We go the integral from 4 to 7, right? Because whenever we're between less than 7, we deal this guy, sine of 3x minus 4. Plus the integral from 7 to 9, because that means once we get to 7, we're living on this guy. We have to end at 9 of 3 over 2x minus 1 dx. Forgot a dx on the first one. But it just becomes 2 integration problems. Not really a big deal. All right. I'll give you a moment to catch up and copy that. So now, we have this guy here. And this is a little weird. I give you a graph and I ask you to calculate some integrals. And the important thing here is it's just area under the curve. So normally when you do a problem like this, on the AP exam, they would tell you what these shapes are. But what I have here is I'll highlight it. This is a straight line. This is a semicircle. And these are two more straight lines. Okay, two more straight lines. Let me do a little erasing because I don't want that a problem. So if we want to go from 2 to negative 6 to 2, excuse me, what happens, that is this area under the curve from here to here, right? So that means I have to calculate, say, this area, because it's the area between the curve and the x-axis. I have to calculate that area. And I also have to calculate this area. Okay, well, it's not that bad. This is a triangle. It has height 2. It has width, 1, 2, 3, 4. So this triangle is 1/2 base times height. So this is 1/2 of 8. This guy has area 2 times 8. Half of 8 is 4. This guy has area. Oops, I should probably do it in green. This guy has area. Wrong green. Area 4. Then we do the watermelon down here. This guy is red. It's a semicircle, so it's half of a circle. The area here is going to be 1/2 pi r squared. R is 2, so this is 1/2 pi times 4, which is 1/2. 2 pi. This is 2 pi. So that's the raw area, but remember this area occurs below the x-axis, so this all has to be negative. And then for my final answer here, I get negative 2 pi, and I get 4 minus 2 pi, right? And I just get, that's the answer, 4 minus 2 pi, I guess units squared. Okay, so I think most of that's okay. There are just a few little tricks in here. All right, the one thing you have to look out for, and I'm going to ask you to do the rest of these problems, it's just some kind of basic geometry, but the one thing you do have to look out for is, for instance, in number 5, the bounds are in the wrong direction, right? Instead of between 0 and negative 6 and 0, I'm between 0 and negative 6. So all that changes, that sounds like it might be a big deal, but all that changes is the sign of the answer. So I just do it like I normally would. I mean, maybe we'll do that one. I want to go from 0 to negative 6, so that's here to here, right? So again, I got this triangle. So this is 4, we did that already. And then I got this bit here. This is a quarter circle, so this is 1/4 pi r squared. R is still 2, so this is 1/4 pi times 4, which is 1 over, so it's just pi. Right, and again, since this is below the x-axis down here, this is negative. All right? So then our area here really is 4 minus pi, but our bounds are in the wrong direction. So really our answer is negative 4 minus pi. We have to put a negative sign in there, which we then could write as really, this is equal to pi minus 4. All right, if I distribute that minus. So look out for your bounds in the wrong direction. Do the rest of these problems as well. Here we got some kind of mind twisters with even and odd functions. Good luck. See if you can figure them out. They might be a little challenging, but you could do it. Like, all you need to know is the stuff I said up above. I'm pointing in the air right now, and you can't see me. Okay? Here's a problem that we really haven't had a huge amount of time to practice, but I thought I'd throw one of these on there. And then one of these problems that I promised that they would be doing, right? So I want you to do this problem as well. Which of the following is this integral equal to? All right, which of the following is this integral equal to? What you would do is just carry out your u substitution and continue on from there. Then you have a few more problems down here as well. These are two straight lines, and this is a part of a circle. So that's kind of a quick video for this evening. You do have a lot of problems to do here. I want you to calculate a bunch of stuff down here as well. So what we'll do is we'll have this due on Monday. So you have the weekend while you're not at Halloween shenanigans to you can do some math. So I'll have this be due on Monday. Other than that, guys, good luck and have a great weekend.